Okay, so welcome to Guided Study Group week 4. So it's more like an exam review than doing other stuff like the rest of the week. But I wouldn't go through like a massive and detailed exam review because I think Dr. Kasha already did once and Dr. Bang Seung-hoon also did one. So I wouldn't want to like repeat that again. Yeah, for the rest of the people in the group, in the meeting, please put your PSU email into the chat room so that I can keep track of the attendance because I have to report it to my boss. So now we're gonna get started. So kind of like I'm gonna have like a quick checklist of what you need to know, but it's just the main thing and it's not everything. So it's not inclusive of even like the small detail stuff like algebra and all of that. So you guys will have to again go through the slides and the lectures on your own if you need to review if you want to make sure that you don't miss anything. But these are the thing here is just the thing that you must know. So the first week I didn't do the sessions on that, but I think the slides is very detailed on log and exponential. So things about log and exponential is that maybe you know like the general property, like maybe even things like ln of a plus ln of b is ln of a multiplied b, something like that. Or you can have like a quotient if this is the minus as well. And then we have log derivative and integral of log and exponential. So this is the must-know thing so that you can do the rest when we talk about integrations and stuff. Then we have log differentiation. So log differentiation is just allowing us to take and find derivative of a complicated function of x, so say x, y equal x to the x. Then we have inverse trig function. So again, in this sessions, I have a very nice table that summarizes everything, including the domain, the range, and also like you need to know the general shape of the graph, like what is the graph of inverse secant and inverse tangent and inverse sine. Yeah, how to convert inverse trig of a trig function and the other way around, and also use the right triangle formula. So the right triangle formula is really important for taking integrations as well, especially when you do trig sub, then you have to put it back into the form of x after you do trig sub. Then we have a bunch of like integration techniques. So integration by part, into inverse trig integral, trig sub, partial fractions, and we also have a section last week called strategies of integrations where you have to use more than one technique. So each of these must be reviewed in detail so that you can like master it to prepare for the exam. Yeah, so before I go any further, is there any questions with any piece of materials at all? Because the rest is just I look at some of the practice exams that people already did, like kind of their grades and all of that, and just pick out some of the questions that I saw people get wrong often. So if you want me to go through any specific questions, I can do that as well. CW, give me a second, I'll note down the PSU email right now. So yeah, so okay, let's go to the first questions. So it's question 3 of the practice exam. Find the inverse, the derivative of the inverse at 1 for fx equals square root of x cubed plus x squared plus x plus 2. Now, let's see what it's gonna give us. So what we have in the first, in I think, I don't know, the first week or the second week, but we have this formula of this derivative is going to be 1 over the f prime of inverse of 1. And so all we need to find is that we need to find what is the inverse of 1. And then we find f prime of that value. So we have inverse of 1 we need to find, and we need to find f prime of, say, a. Now, if we look at this, fx is equal to square root of x cubed plus x squared plus x plus 2. We have to find a value of x that give this entire value equal to 1, or just the inside equal to 1, because square root of 1 is 1. So then we have to find x cubed plus x squared plus x plus 2 is equal to 1. And I think I would say the approach is that you plug in the simple numbers like 0, 1, or -1 and try to see which one is going to give us. Usually, I think because this exam say you wouldn't be able to use calculators, they wouldn't give you crazy number at all. So in this case, if you plug in different small numbers, what you end up having is you're going to have x equal to -1. So because it's a one-to-one function, so this is like the only solutions. So we have inverse of 1, a is going to be -1. And so we have to find f prime of -1. So what is exactly is f prime first of all? So we have to find derivative of that. Which is now going to give us 3x squared plus 2x plus 1. 2 square root of x cubed plus x squared plus x plus 2. So now we plug in f prime of -1, which is going to be 3, -2 plus 1 divided by 2 square root of 1, which is going to give us 2 over 2, which is again 1. So you have this one is 1 over 1, which is going to give us 1. So is there any questions with this part? Because this is a multiple choice questions, so usually yeah, so usually it's the multiple choice questions. So I didn't do one of the part here, which is supposed to be you have to prove that this function has its inverse exists on negative infinity to infinity. But this is a multiple choice question, so I figure there's no way you need to demonstrate that it's a one-to-one function. Yeah, but I mean, you should also have a check if it's an one-to-one function by finding the derivative and see if it's only increasing or decreasing. Then you can conclude that it's a one-to-one function. So if we good with this, let's go to this questions. I don't know why it's still question 3. Maybe I make a mistake here. This should be question 2. Okay. Find the limit of x approaching infinity of absolute value of sine x over x. Before I do this, I'll give you guys like 30 seconds because I think this one is kind of like an interesting one and I want you guys to try working on it. So yeah, work on this and see how it goes. I'll give you like a Okay, so we're gonna go and continue with this. I think this question is just mainly like a kind of like review of the old knowledge. I don't think it really have much to do with our materials, but we can work on that. So here at x approaching infinity, absolute value of sine x over x. I mean, when x approaching infinity, you have this limit is going to be absolute value of sine x over x, because x here is positive, so you can take it out of the absolute value. Now we have if we remember something in 141 called the squeeze theorem 140, so then it will make our life so much easier, because now you can use the squeeze theorem to resolve the problem. So you have absolute value of sine x is always going to be between 0 and 1. So sine x itself is between -1 and 1. But when you take the absolute value, it has to be only positive, so you go from 0 to 1. And so you have limit of x approaching infinity of 0 over x is equal to limit of x approaching infinity of 1 over x, which is just going to give 0. Therefore, the thing inside limit of x approaching infinity, sine x over x, absolute value of sine x actually, is also going to be 0. So is this a strange one, but it doesn't mean that we cannot solve the problem. So yeah, that's some of you might forgot the squeeze theorem already, so that might be the only challenging thing here. But other than that, it's nothing really complicated. So I'm going to go ahead and proceed to the next questions. So again, find this limit, and now I think it's kind of related now, because when it started to go with inverse function. So we have limit of x approaching 2 minus inverse tangent 1 over 4 minus x squared. Now, when x approaching 2 minus 4 minus x squared, where does 4 minus x squared going to? So we have x approaching 2 minus 4 minus x squared. So when x approaching 2 minus, it's a smaller number than 2. And when you square it, it's a smaller number than 4. So this thing is going to approaching 0 plus. Therefore, this entire thing is limit of x approaching 2 plus inverse tangent of 1 over 0 plus, which is going to give you to infinity, inverse tangent of infinity. Now, for inverse tangent, if you remember the graph, and I always use a graph, so that's like the only thing that I actually remember, is that this is the graph of it. So it's like pi over 2, negative pi over 2. So this is the graph of inverse tangent. So at x approaching infinity, like as the value inside the angle, the value approaching infinity, it's going to approaching pi over 2. So in this case, our answer is going to be pi over 2. So yeah, again, nothing really bad. It's just like a lot of review of the graph and the range. I heard someone voice. Do you have any questions with what we're doing? Oh yeah, Emily, by the way, you should put in your PSU email in the chat room as well. Like in the chat, so like I can keep track of the. Okay. Okay, cool. So let's go. Oh, what just happened? Give me a second. I think I dropped something. Oh, it's mouse. Dang it. Okay. So let's go ahead and go to the next questions. So question 6, if fx is equal 3 to the x, then the 101st derivative of that function is given by what? I think it's a very interesting question. I remember it was seen in my exam earlier when I was taking this class, but I haven't really seen it since then. So I put it back in so so that people can work on it. I also saw like based on the number of people I saw did the practice exam, a few of them get this one wrong. Maybe it's just because of the fact that they've never done this one before. So let's see how it goes in here. So you have f(x) is 3 to the x. When you take, just like basically you find a lot of derivative of that and start to find the rule of this. So you have the first derivative is 3 to the x ln of 3. Then we have the second derivative is 3 to the x ln of 3 square. Or basically you take this derivative of this first one and multiply ln of 3 that we have here. So basically it's just 3 to the x ln of 3 square. And if you continue to do the third one to find the rule, usually we have to do like 3 times to see the rule. So it's going to be 3 to the x ln of 3 cube. So I would say here we kind of like see the rule that whatever the derivative over here, you're going to have the power of ln of 3 over there. So if we take the 101 derivative of f(x), we're going to have 3 to the x ln of 3 to the 101. So pretty simple, but most of the time we just have to find the rule of what is it leading to. So sometimes it doesn't end up just like 101. Sometimes for some specific function that they just change the value in, just change the power here, then they're gonna end up with like maybe 99 or like 100 or something like that. So this is yeah, and then the key here is know what is derivative of a log function, a power function, exponential function. Sorry. Yeah. So I think we can 3 square. So this is square. So we can go ahead and go to the next one, right? Evaluate this integral from 0 to pi over 3 x secant square of x dx. So this one, we have two kind of functions here. First is polynomial, and then we have trig. So I would say the first thing coming to mind is I'm going to use integration by parts. So we have x secant square x dx. So I'll put u equal x, du is going to be dx, dv is secant square x dx. So then we have v is tangent x. So this part is going to give us x tangent x minus 0 to pi over 3 tangent x dx. And in this case, we just need to know what is the derivative of tangent x, and that is going to be ln of absolute value of secant, and it's going from 0 to pi over 3. So in this case, the challenging part here is remember what is the integral of tangent, which is going to be ln of secant. So now we have it's going to be, let's see. So we have this one, and we just plug in numbers. So pi over 3. Tangent of pi over 3 is going to be square root of 3 minus ln of. So secant is 1 over cosine. Cosine of pi over 3 is half. So you have secant is going to be 2, ln of 2. And then when you plug in 0 in the next one is going to be 0. And then you have minus, and minus is a plus. Plus of ln of secant of 0 is 1. So it's ln of 1, which is again 0. So what we end up having here, the answer is pi square root of 3 over 3 minus ln of 2. So yeah, that's the final answer for this. Nothing really complicated. The tricky thing here is what is integral of tangent. So let's go ahead. I don't know why someone might have get wrong. So I guess maybe the mistake that can be made here is when first they don't remember what is integral of tangent, or when they plug in That is the problem, because I think the algebra and the numbers might be a little bit confusing to some people as well. Now it's question 16. Evaluate this integral, tangent square plus tangent fourth dx. So we have here tangent square x plus tangent fourth x dx. So before I get started, just want to ask the questions here. What do you think that I should use here? I just want to make sure that you guys are kind of like somewhat prepared for the exam. So just put whatever you think the strategy that I should use in this questions, so that I can see like maybe what people think on this. So tell me what do you think that I should do for these questions? That is true. Pull out tangent square and integrate by parts. Break tangent fourth down into 2. Okay, so I think yeah, I think we have what is going on here, but definitely there's a thing that I should notice. I don't think integration by part is a thing. It's the key here. You can try doing it, but then it's gonna lead you to actually more complicated function, even though the purpose of doing integration by part is to simplify it. That is because here we don't have like the two functions together. So if you look at here, I think I mentioned last week and also in my sessions when I talk about integration by part, is that this technique should only be used if you have two different functions. So say if you have log and trig, or like polynomial and trig and so on, something like that, then you gotta use integration by part because that help you to simplify the function. However, in this case, we only have trig, so I wouldn't say integration by part is a good choice. But that is good to talk about because then you don't make that mistake in the exam, right? So here, that is correct that we should pull tangent square out, and what we have left inside is 1 plus tangent square dx. So what is end up giving us is this one's going to be tangent square multiplied secant square x dx. Now, here is when we can use the u sub. So if you put u equal tangent of x, then you have du is going to be secant square x dx. And that is simplified this part. So it's going to be integral of u squared over u, which is going to give us u cubed plus c, or is it just tangent cubed over 3 plus c? Yeah, so that's my final answer for this. Yeah, so the tricky thing here is figure out that the fact that you have to pull tangent square out and see that 1 plus tangent square is actually the derivative of tangent, so that you can use the u sub. So yeah, again, this one, the hard key, that's the challenging part. Now let's go to the next questions. It's question 19. I think some of the people got this question wrong because they were not familiar with like breaking the fraction, especially when it's too simple like this. So partial fractions kind of like give us the practice that we can break down the very massive fraction. But now I figure some of the easier one and simple one can cause people trouble as well because they used to like overthink the problem. So the way that I'm going to do it here, as I said, is break it down into smaller fraction. So let's write it. So here, what I usually do is that I'll just base on the number in the denominator and kind of like adding or minus something in the numerator. So to keep it to kind of like simplify something. So here when you have 4x and then in the denominator you have 2x. So you have dx. So you have 2x minus 1. So 4 and 2, there's like a fraction of 2. So what I do is that I take 2 out. So inside I'll have like a 2x minus 1. So if I do this, this fraction is going to become 4x minus 2, but over on the left, I have 4x plus 2. So I have to keep it the same because this is like an equality here. So from negative 2 here to plus 2, I need to add 4. So now you can simplify it because you can break this fraction out as 2x minus 1 over 2x minus 1 plus 4 over 2x minus 1. And this entire thing dx. Now it's easier because here you can simplify it, which is just going to be 2 plus 4 over 2x minus 1. Actually, I think the tricky thing here is we start to deal with improper integrals. But I don't think we have been introduced here to do that. Give me a second. I mean, you can do long division, but it's like a complicated way to approach it. Actually, I think it would be a better idea for me if I look up the... Give me a second, guys. You can still work on it when I escape out. Because I think there is maybe like a mistake in the denominator. Because that's going to be something related to the second exam. 2 plus 3. What do you mean by 2 plus 3 over 2x minus 1? Why is it plus 3 and not plus 2? Really? Okay, give me a second. I'll do long division right now. I don't think it's the case, but it's 4x plus 2 divided by 2x minus 1. Then maybe I make the mistake somewhere. Oh, it's 4x plus 2, not 4x plus 1 divided by 2x plus 2 divided by 2x minus 1. The result of long division, if we do that, is going to be 2 multiply 2x minus 1 plus 4. Okay, give me a second. I'm checking the answer for this. Because, yeah, I mean, it's related because the denominator is not defined in this scenario. So just want to make sure that we get it correct. Let's look at the grades. The thing is, some people actually did more of the practice exam already. So I feel like if I'm looking at this, just to see the number of people who did it, I would say around half the class already did it. So it's good practice. Give me a second. I'm pulling up to that question. Okay, so I think Dr. Kasha might have forgotten something here. Okay, I'll warn her about this. But yeah, the general way you can do this is okay. Let's go back to our part. So technically, we can do it this way until we get to the final exam. I'll ask her to remove these questions. I think she might have forgotten something, or like put the wrong number in instead of minus 1. It can be plus 1. But anyway, here we have let's go back. So here, after we get to this point, the thing we need is just to plug in and find maybe, oh, not plug in. Here we have to take the integral first. So we have 2x plus, and I think you make a mistake as well, Kyrie. I don't know Kyrie, but anyway, when you take this integral, you have to take care of the fact that the derivative of the denominator is 2. So it's gonna be 2 multiplied 2x minus 1 dx from 1 to 2. And that is going to give us 2x plus 2 ln of 2x minus 1 from 1 to 2. So if you say instead of 4 you have 3, so the integral should be 3 over 2 multiply ln of that. So here we have, if you plug in, it's going to be 4 plus 2 ln of 3 minus 1, minus 2 ln of 1, which is minus 2 ln of 1, which is just 0. So what we end up having is 2 plus 2 ln of 3. Yeah, so that's what we have for this session. So this question, not too hard. The thing is to be able to, sorry, not there yet. The key thing here is to be able to break it down and not make any mistake during the long division or the algebra part. So before I end this sessions, I would like to ask if any of you have any questions with the practice problems that I put at the end of last week sessions. So I feel like those are definitely more challenging than these questions here, but it's good practice for the exam, especially for someone who is looking for extra practice, because those are like more hard, like much harder than this. But I figure we're gonna help you prepare like kind of like mentally for how hard it is can be in the exam. But if you don't have any more questions or haven't tried it out, please feel free to try it out during like your exam review if you have time, and let me know if you have any questions. If not, good luck for your exam, and I'll see you guys next week. How's that? All right. Can you explain why you put the 2 out? Okay, cool. I can do that. So here, did you so your question is, when you explain why you put the 2 out of the 4? Okay, so because when we take derivative, if you want to say integral of absolute value of 2x minus 1, then you need so when you have ln of 2x minus 1, right, the derivative of this is going to be 2 over 2x minus 1, because it's du over u, right? U here is 2x minus 1 and du is 2. So that's why you need the 2 here to change this entire thing into take integral of that to become ln of 2x minus 1. Do you see why I'm doing that? Okay, cool. So yeah, that's all we have. And all right, I'll end the sessions here, and I hope you guys have a great weekend and a wonderful exam.